Hi students, welcome back to math lesson. Today we are going to learn about increasing and decreasing function and stationary points. These two topics are related to the differentiation that we have learned. Let's check this out.
Let's start with some definition of increasing and decreasing functions. For increasing functions, if x1 is less than x2 implies fx1 less than fx2 for all values of x1 and x2, fx is an increasing function. For decreasing functions, if x1 less than x2 implies fx1 greater than fx2 for all values of x1 and x2, fx is a decreasing function. Take a look for this illustration. We have a Cartesian diagram with the graph of y equals fx equals x. Take 2 points on the graph. The first one is 1, 1 and the second one is 3, 3. So here we have x1 equals 1, y1 equals 1 and x2 equals 3, y2 equals 3. It is obvious that x1 is less than x2 implies y1 less than y2. Since we know that y equals fx, so we can say fx1 is less than fx2. So this is an increasing function. Meanwhile, the gradient of this function is 1, which is greater than 0. We will see the use of the gradient in the next section. Let's have the other example for decreasing function. This is the diagram of y equals fx equals minus x. Take 2 points on the graph. The first one is minus 3, 3 and the second one is minus 1, 1. Here we have x1 equals minus 3, y1 equals 3, x2 equals minus 1, y2 equals 1. Obviously, we have x1 is less than x2. Implies y1 greater than y2. Because y equals fx, so we write fx1 larger than fx2. Meanwhile, the gradient is minus 1, which is less than 0. Remember that the gradient of a function is actually the first derivative of that function. So we can define increasing and decreasing functions in more elegant way. For increasing functions, if f prime x is larger than 0 for all values of x on an interval a less than x less than b, fx is an increasing function. Remember that the f prime defines the gradient. For decreasing functions, if f prime x is less than 0 for all values of x on interval a less than x less than b, so fx is a decreasing function. Again, the first derivative defines the gradient. Here is an example. Explain why gx equals minus 3x minus 2x to the power of 5 is a decreasing function for all real values of x. Gx is a decreasing function when g prime x is less than 0. That's what we are going to look for. So gx equals minus 3x minus 2x to the power of 5 and g prime x equals minus 3 minus 10x to the power of 4. Remember, when we substitute any value of x into x to the power of 4, so the value of x to the power of 4 is greater than or equal to 0. So here, we can conclude that g prime x equals minus 3 minus 10x to the power of 4 is actually less than 0 for all x, or we can say g prime is negative. So here, gx is a decreasing function for all values of x. This is the other example. If gx equals x cubed minus 7x squared minus 5x plus 30, determine the intervals of values of x on which gx is increasing. Based on the question, gx equals to x cubed minus 7x squared minus 5x plus 30. G prime x equals 3x squared minus 14x minus 5. Because gx is increasing, so g prime x equals 3x squared minus 14x minus 5 is larger than 0. Factorizing this will give 3x plus 1 times x minus 5 larger than 0. Solving this inequality will give x less than minus 1 over 3 or x larger than 5. This is the other term that we learned today. The stationary or critical points have a definition. A point at which f prime x equals 0 is called a stationary point. Here are types of stationary or critical points. There is maximum, minimum, and stationary point of inflection. We will discuss about these terms later. This is the other term that we should know. Turning point. A turning point is stationary point, which is either maximum or minimum. To know which one is the maximum, minimum, or stationary point of inflection, we have the first derivative test. If the first derivative f prime x equals 0, and the sign of f prime x changes from positive to negative around x0, then fx0 is a maximum value. In other words, x0, fx0 is a maximum point. If the first derivative equals 0, and the sign of f prime x changes from negative to positive around x0, then fx0 is a minimum value. In other words, x0, fx0 is a minimum point. If the first derivative f prime x equals 0, and the sign of f prime x does not change around x0, then x0, fx0 is a stationary point of inflection. Consider the function fx equals x cubed minus 12x plus 11. Find the stationary points of the function. Determine whether each stationary point is a maximum or minimum point. So to find the stationary points of the function, must be f prime x equals 0. So fx equals x cubed minus 12x plus 11, and the first derivative f prime x equals 3x squared minus 12. So for stationary point, f prime x equals 0, 3x squared minus 12 equals 0, and solving this, we obtain x equals minus 2 or 2. By substituting the values of x into the function f, so we obtain f minus 2 equals minus 2 cubed minus 12 times minus 2 plus 11 equals 27, and f2 equals 2 cubed minus 12 times 2 plus 11 equals minus 5. So we have the stationary points are minus 2, 27 and 2, minus 5. For part B, we use the first derivative test. Here is the table showing the sign of changes of f prime x around x equals minus 2. So this is the sign of left of minus 2, and here is the right of minus 2. So we take any value on the left of minus 2 to test the sign of f prime, whether it is positive or negative on the left of minus 2. So I take the value of x equals minus 3 and f prime minus 3 equals 15, which is positive. And I take x equals 0 at the right of minus 2 and f prime 0 equals minus 9. Now we can say the sign of f prime x is positive on the left of minus 2 and negative on the right of minus 2. So, since the sign of f prime changes from positive to negative as x increases through x equals minus 2, we can say minus 2, 27 is a maximum point. This is the table showing the sign of changes of f prime x around x equals 2. So we need to take the test for x on the left of 2 and the right of 2. So take any value on the left of 2, let's say x equals 0, so we have f prime 0 equals minus 9, so the sign is negative. And take any value on the right of 2, so I take here x equals 3, so f prime 3 equals 15, which is positive. So we can say the sign of f prime x changes from negative to positive as x increases through x equals 2. So the conclusion is 2, minus 5 is a minimum point. We also have the other method to find out whether a stationary point is a maximum or minimum point. So second derivative test say if the first derivative equals 0 and the second derivative is less than 0, then y equals fx has a maximum point at x0, fx0. If the first derivative equals 0 and the second derivative is larger than 0, then y equals fx has a minimum point at x0, fx0. Here is the example. Find the maximum value and the minimum value of fx equals x squared minus 3 over x plus 2, where x is not minus 2. So, based on the question, fx equals x squared minus 3 over x plus 2. The first derivative using the quotient rule is x squared plus 4x plus 3 over x plus 2 squared. Using the quotient rule, we also have the second derivative f double prime x equals 2 over x plus 2 cubed. For stationary points, f prime x equals 0. X squared plus 4x plus 3 over x plus 2 square equals 0. X plus 2 square is always not negative, so we can ignore this. So it leaves x squared plus 4x plus 3 equals 0. Factorizing this will give x plus 3 times x plus 1 equals 0. X equals minus 3 or minus 1. Substitute the value of x equals minus 3, we obtain f minus 3 equals minus 6. Substitute the value of x equals minus 3 into the second derivative, we obtain 2 over minus 3 plus 2 cubed equals minus 2 less than 0. So we obtain minus 3, minus 6 is a maximum point. In other words, the maximum value is minus 6. Substitute the value of x equals minus 1 into the original function f minus 1 equals minus 2. And substitute the value of x equals minus 1 into the second derivative, so we obtain the second derivative at x equals minus 1 equals 2 over minus 1 plus 2 cubed equals 2 larger than 0. Based on second derivative test, we obtain minus 1, minus 2 is a minimum point. In other words, the minimum value is minus 2.
That's all for today's lesson. If you have some difficulties or questions related to this lesson, let me know. Do your works and please submit it on time in Edmodo. See you again in the next video.
Stay at home, tetap semangat!